Wait, ¿me voy? ¿Se me oye ahora? ¿Ahora sí?
Hola,
Buenas
sí.
tardes a todos. Estamos esperando que Mr. Avi Loeb se pueda poner con nosotros en comunicación ahora mismo. Tardará pues unos 8 minutos más. Sean todos bienvenidos a esta conferencia. Creo que le tenemos ahora mismo en la sala. Vamos a ver si logramos verle.
Hello.
Hello.
Hi. It's nice to see you.
Oh, welcome. Pleased to meet you.
Thank you.
1 minute, only 1 minute. Sean bienvenidos todos. Yo ya voy a hablar con él para darle la bienvenida y sin más preámbulos, ¿sí? Good afternoon, Mr. Avi Loeb. My name is Sandra.
Nice to meet you.
I'm the founder and director of the Starlight Estelar Parque Camino Barranco de Badajoz, located in Guimar, Tenerife, Canary Islands. It's a privilege to have you here with us today and to discover your views about how the Oumuamua could be the first sign of intelligent life beyond Earth. But before that, I would like to introduce you to the person who you'll be talking to by email, and that she's also our daughter too. Her name is Aisha, and thank you and welcome.
Thank you. It's a pleasure to be here.
Good afternoon, Mr. Loeb. I'm Aisha. Pleased to meet you.
Nice to meet you.
We're delighted to have this opportunity. As Sandra said, it is a privilege to have you here with us all today. You are most welcome, and with further ado, I shall give you the floor.
Thank you so much, Aisha, and I'm particularly pleased to recognize that you are relatively young because my book addresses mostly the young generation. You know, I don't have great hopes with the more senior people because, you know, just like Marie Antoinette did not embrace the French Revolution, I don't have that much hope that things will change quickly. But the younger generation, when that occupies the halls of academia, perhaps will have a better future then. So let me share my screen. Hopefully I can do that. And then, oops, can you make me a host, a co-host, so that I will share my screen and show the slides, please?
Yeah, sure. Try it now.
Okay. Yes, it works.
Okay.
Excellent. I hope you can see my screen.
Yes, we
so
see
let
it.
me, okay, so I will, and then of course at the end, I will be glad to answer any questions that the audience has. Okay, so in this talk, I will focus on the content of my book, Extraterrestrial, which was published also in Spanish. It will be published in 26 countries worldwide. And I'm particularly proud of the Spanish edition simply because half of my DNA is of Spanish origin. And that's the good part, actually. So if I had to summarize my book, I would say, when you're not ready to find exceptional things, you will never discover them. And I wrote a Scientific American article about it that you are welcome to have a look at. And on the left here, you see a photograph of a photograph that appeared in an exhibit called Fascination of Science by the photographer Herlinde Quilbel from Germany. That exhibition was presented in Berlin in October 2020, just a few months ago. And she asked me when she visited my office to write down on the palm of my hand what is the most important question that I consider in science, and I wrote, are we alone? So let me start with an excerpt from the book. And basically it underlines the fundamental principle that I learned from studying the sky as an astronomer, professional astronomer, over the past several decades. And that perspective is of modesty. The one thing that the sky teaches us is to be modest and never be arrogant, simply because we are so small. But moreover, we live a short time, we know so little. So let me start with this excerpt. Both
me,
of my
Mr.
parents passed.
We couldn't see
Yes?
what you are sharing with us. We can see
Really?
anything. Yeah, really. Can I help you with
Okay.
something?
Let me see. Is the screen share not available?
In Spanish.
Let me try again.
Okay.
Share my screen. Can you see now?
No.
I guess perhaps it's not sharing my screen. Can you make me a co-host? Because for some reason it's not allowing me to share the screen.
Yeah, you are already. You are already a co-host.
Okay, let me see.
Okay.
Let's try it again. Can you see me now?
Yeah,
It's
now we
okay.
see it.
Now it's okay.
Yes.
Okay, great. In fact, just one second, let me make it full screen so that, can you see it now?
Yes, we perfectly
Full screen?
see it. Yes.
Okay, perfect. Okay, so let me just show you the first slide since you missed it. This is the first slide that I was talking about. It shows the cover of my book, and also this photograph of a photograph that was presented in Berlin in October 2020. So here is the excerpt from my book. My father, David, was laid to rest in the same red soil in which he planted trees all of his life, in the vicinity of those plantations that he watered routinely, near the house that he built with his rugged hands, and that I grew up in, surrounded by the people he loved and who loved him in return, under the blue sky that I study as an astronomer. My mother, Sarah, who put me on the road to thinking as a philosopher, with whom I spoke daily throughout my adulthood, and who especially gifted me with the life of the mind, was buried beside him 2 years later. In astronomy, we realize that matter takes new forms over time. The matter we are made of was produced in the hearts of massive stars that exploded. It assembled to make the earth that nourishes plants that feed our bodies. What are we then, if not just fleeting shapes taken by a few specks of material for a brief moment in cosmic history on the surface of one planet out of so many? We are insignificant, not just because the cosmos is so vast, but also because we ourselves are so tiny. Each of us is merely a transient structure that comes and goes, recorded in the minds of other transient structures. And that is all. So what I really have a hard time accepting is a sense of arrogance that some people showed throughout human history. And here you see a picture of a king that was very proud of himself. Usually, these pictures were of alpha males that, showed strength and are resilient after conquering a piece of land on earth. But we know that the Earth is just 1 out of 10 to the power 20 planets that have similar conditions in the observable volume of the universe. There are more habitable Earths than grains of sand on all beaches on Earth. We know that about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. So how can anyone be arrogant? I mean, this gives you a sense of cosmic modesty, because conquering a piece of land on Earth is equivalent to an ant hugging a single grain of sand on the landscape of a huge beach. It's nothing to be proud of. And I can sort of understand where it comes from, this sense of arrogance, because when my 2 daughters that you see here in the picture, when they were young, they tended to think that the world centers on them and that they are the smartest in the world. And of course, once we took them to the kindergarten, they recognized that there are other kids, some of which are smarter than they are. So they got a better perspective about reality. And so our civilization will mature only when we go out to the cosmic street and find others. If we keep ourselves at home, then of course we would continue to have this illusion that we are the smartest and that there is nothing like us. And I don't think that's the case. I think we're probably middle of the road, not necessarily the smartest kid on the block. We are not the sharpest cookies in the jar. And by the jar, I mean the Milky Way galaxy. And I base that on looking at the morning news every day. We are doing not very clever things. Intelligence, as far as I define it, is trying to promote a better future that matches your interests. And we are not doing that. We are fighting each other. We are wasting a lot of resources on actions out of which nothing constructive comes out. So there might be more intelligent civilizations out there. Moreover, we developed our technologies only for 100 years. And the universe existed for 13.7 billion years. And most stars are much older than the sun. Most stars formed billions of years before the sun. So, you know, if there are civilizations out there, technological ones, they had much more time to develop their technologies. Now, Earth is our home. And I should tell you, I was born on a farm, so I very much appreciate nature. And I realize that your organization it promotes a connection to nature, and I salute that initiative. I'm connected to nature much more than to people. And Earth is, of course, our home, but not for a long time, because there are internal threats, you know, climate change, nuclear, biological, or chemical wars that we could initiate. These are self-inflicted wounds, pandemics, as we all know from the past year, and of course, political and technological catastrophes that could happen. But there are also external threats. For example, an asteroid may impact us. And for those people that say, oh, we don't need to worry about the sky, let's just focus on our problems here at home. What I tell them is, you know, look at the dinosaurs. They enjoyed eating grass all day. They didn't worry about the sky. And then 66 million years ago, a giant rock, bigger than the size of Manhattan Island, showed up on the sky, and it got bigger and bigger, and the fun stopped when it hit the ground. 3/4 of all life forms on Earth went extinct as a result of that. So you could worry just about what happens locally and not even worry about the world news, but at some point there would be a virus in Wuhan, China, that will arrive to your doorstep. So even if you don't read the world news, you will be affected by it. So it's really important to know about the big picture, to know about your environment. And the bigger environment includes the stars around us and includes possible civilizations out there. We might not be alone. We should know about it. It's good to know who is in your neighborhood. Just a few words about my background. So actually, just a couple of days ago, I turned 59 years old. My birthday was on Friday. And I was born on a farm, as I said, connected to nature more than to people, so to speak. And you can see me at the second photo on the left, collecting eggs. That's what I did every afternoon. I haven't changed much, by the way, from that kid, pretty much the same. And then in the middle photo, you can see me riding a tractor with my sister next to our home. I used to ride the tractor to the hills of the village and read philosophy books. I was mostly fascinated by questions in philosophy because they are the most fundamental ones that we have about our existence, about our lives. But then by circumstances, I was born in Israel. I had to serve in the military, and I chose to do intellectual work related to physics for the defense of the country. And as a result, I became a physicist and then an astrophysicist, ended up at Harvard and was chair of the astronomy department there for 9 years, the longest serving chair. On the right here, you can see my family. I'm very blessed, surrounded by 3 women, my wife and 2 daughters. And then at the bottom left, you can see a visit that took place in May 2015. So basically a black limousine parked in front of the Center for Astrophysics at Harvard, and out of it came an entrepreneur from Silicon Valley named Yuri Milner, and he entered my office, sat on the sofa in front of me, and asked me whether I'm interested in leading a project to visit the nearest star within our lifetime. And of course, the nearest star is 4 light years away. It takes light 4 years to traverse the distance. So I immediately recognized this is not an easy challenge. You need a spacecraft that moves at about 1/5 of the speed of light if you wanted to get there in 20 years. Now that's a factor of 1,000 faster than the best rockets that we produced. It's not easy to get that, 1/5 of the speed of light. So I told Yuri, I'll have to think about it with my students and postdocs. And 6 months later, I recommended the concept that I'll describe in a minute. So here is a picture of the solar system. You see the sun on the left, and then the Earth. And at 10 times the Earth-Sun separation, you find Saturn. And then at 100 times the Earth-Sun separation, you find the region where the wind coming from the sun, the so-called solar wind, is stopped by the gas that fills in the void between stars, called the interstellar medium. So that's where the solar wind is stopped, but it's not the edge of the solar system. Most of the solar system volume is occupied by the so-called Oort cloud that contains a lot of icy rocks left over from the building blocks of the solar system, sort of like Lego pieces that were not combined to make bigger structures. So these are just the pieces, the rocks that were left behind from the construction project of the solar system. And they're floating in a sphere around the solar system. They were kicked out, and they're called the Oort cloud of objects. And these rocks, every now and then, some of them get close to the sun. And when that happens, the ice on the surface warms up and evaporates, and you end up with a cometary tail. And these are called long period comets. Now, the Oort cloud goes out to a distance of 100,000 times the Earth-Sun separation, very large distance, which is halfway to the nearest star, Proxima Centauri, which is a member of the Alpha Centauri system, having 3 stars in it. So the Oort cloud is halfway to the nearest star, and if the nearest star has an Oort cloud around it, then these Oort clouds touch each other. They're sort of like billiard balls that are densely packed, all the Oort clouds of all the stars. So when stars move relative to each other, some of the outer members of their Oort clouds can be ripped apart and populate interstellar space, the space between stars, and these would be interstellar objects. So we expect some rocks to be in the interstellar space, but when we try to calculate how many, found with two collaborators, Martin, who is Spanish in origin, and Ed Turner, found that we don't expect the current survey telescope pan-stars to find any interstellar objects. The number was for it to find any. Now, the nearest star is Proxima Centauri, and it has a planet that is 20 times closer to the star than the Earth is from the sun. And because the star is very faint, it's just 12% of the mass of the sun. Turns out that this planet is in the habitable zone because the day side of this planet has a temperature similar to room temperature. So it could potentially have liquid water on the surface. The planet is so close to the star that there is a permanent day side. It always faces, it's tidally locked, just like the moon is to the Earth. This planet is to the star, showing the same side, the same face at all times. There is a permanent day side and a permanent night side. And my daughters say, well, the highest value for real estate will be exactly in the strip between these two sides, because that's where the star never sets. It's the permanent sunset strip. And it's beautiful to be in a house there because you always see the sunset forever. The sun never sets in that strip. The other interesting point is this planet moves around the star every 11 days. So if there are any living creatures on it, they celebrate their birthday every 11 days. There are lots of parties over there. Finally, this star is so small that it emits mostly infrared light, in difference from the sun that emits visible light. So that means if there are any creatures there, they have infrared eyes. And what that means is that if there are any interstellar tourist agencies there, they would never send creatures to Earth because we have visible light and that would hurt their eyes. And also all of our vacation sites have green grass and they are used to dark red grass. So they would never find the Earth to be an appealing tourist destination. Maybe that explains why we've never seen them. We have to go there and entice the locals to come and visit us, offering them a water-based drink. So how do we go there? The idea that I proposed to Yuri Milner was to use a very powerful laser that pushes on a light sail. A light sail is just like a sail on a boat, except it's pushed by light instead of the wind. So if the laser is 100 gigawatt and the light sail, the sail is a few grams in weight, then within a few minutes, you can in principle push the sail to a fifth of the speed of light. The sail has a dimension of order the height of a person, a few meters. And you can equip the sail with electronics that also weigh less than a gram, actually. You find it in cell phones these days already. And the electronics can contain a camera, navigation device, communication device. So this was the concept. And the acceleration distance of this sail would be about 5 times the distance to the moon. So let me show you a video that illustrates the concept. The idea is to have a lot of small lasers that combine their beams and shine on the light sail that is released from a mother spaceship above the atmosphere so that it doesn't feel the friction. And then this powerful laser beam, 100 gigawatt or so, shines, is focused on this laser and pushes it within a distance 5 times the distance to the moon after a few minutes, roughly to a fifth of the speed of light. And just to give you a sense, it takes only a few days to reach Pluto. The time it took New Horizons to do that was 9.5 years. So this is really a revolutionary technology if we can achieve that. It will take, nevertheless, 20 years to reach Proxima Centauri, but the goal would be for this spacecraft to take photographs of the planet and send them back to Earth. And by the way, you can launch a new spacecraft every day. These are very cheap. Most of the investment is in the infrastructure, the laser. So then once the photograph is taken, the signal can be sent back to Earth, and that will take another 4 years to reach us. So 24 years in total. And then the idea is to collect that signal with a telescope. So this is called starshot. But really the most interesting question is not so much whether there is primitive life, microbial life on Proxima b, but are we the smartest kid on the block? And there is no, there is no reason to expect that we are, because on the early Earth, there was a soup of chemicals. And just when you open recipe book for cakes, you find that you can mix the ingredients differently and get very different cakes. So Earth had some recipe to make life, but it's not by all means the optimal one. And you can imagine cakes that are better than us, that were baked on other planets. So without prejudice, let's be open-minded and search. That will be the best way to find the answer. A lot of people have an opinion. They say, oh, we are unique and special and there is nothing out there. Of course, that flatters our ego, but why should we assume that we know the answer before we search? Why don't we just check what's out there? And so the best place to check is in our backyard. Sort of like, if it takes a long time for you to go into the street, the first thing you might want to do is check for objects that came from the street into your backyard. So just look around and see if there are any objects that came from the street into your backyard, and then you can learn about what's going on in the street. So if we look at our backyard, it turns out there was actually an object that arrived to the solar system, to the vicinity of the Earth, from outer space, from outside the solar system. It was discovered by the Pan-STARRS telescope in Hawaii, and was given the name Oumuamua, which means a scout in the Hawaiian language. It was discovered in 2017. You can see this object circled in blue in the middle, and the tracks of dots are background stars that are moving relative to this object. So when you take snapshots, you get dots that are following a line because these stars are moving relative to that object. So here is the motion of that object on the sky when it was, after it was discovered, or actually also before it was discovered based on its orbit. Turns out that it actually started from a very special frame. And you can see the starting point in the top right. And if there is any amateur astronomer in the audience, you would recognize in purple where it says solar apex. What that means, this is the direction towards which the sun is moving in the so-called local standard of rest. The local standard of rest is the frame of reference that you get to when you average over the motions of all the stars in the vicinity of the sun. So it's sort of like the local parking lot. And the sun is moving relative to that frame, just like any other star. Turns out that Oumuamua was at rest in that frame. Only 1 in 500 stars is so much at rest in that frame. That already tells you that it's unusual, because why would it be in that special frame of reference? The chance for that, if it came from one of the stars, the chance for that is 1 in 500. That's one anomaly. It came from that frame, and it behaved just like a buoy on the surface of the ocean at rest. And then the sun, like a giant ship, bumped into it and kicked it. So that's the first strange fact about Oumuamua, aside from the fact that, you know, we didn't expect any rock to be detected by pan-stars in the first place. So the mere detection of an interstellar object was surprising. Then it comes from this special frame of reference. That's another surprising fact. And this is its orbit, which basically means, you know, the initial direction that it came towards the sun is the motion of the sun relative to the local standard of rest. And another anomaly that was shown by Oumuamua is the brightness. As it was tumbling, the brightness due to reflected sunlight, it simply reflected sunlight, the brightness changed by a factor of 10 as it was tumbling. So that means projected on the sky, it was at least 10 times longer than it was wide, so that when it was tumbling, the amount of light reflected changed by at least a factor of 10. And that's very unusual. That's a very extreme geometry. Imagine a piece of paper tumbling in the wind. The chance of it being exactly edge on is small. And a factor of 10 in the area that you see as it's tumbling is quite extreme. It was unprecedented in terms of comets or asteroids from the solar system before. And this is the orbit of Oumuamua. And by the way, it didn't show any cometary tail. There was no gas or dust around it. It was not a comet. So it started on the top. You can see July 29th. That was before we detected it. In fact, I was visiting this observatory on Mount Haleakala, and I was giving a colloquium there. And I was visiting it in July 2017. And back then, we didn't know about Oumuamua. It was discovered on October 19th, which is at the left of this diagram. So by the time we discovered it, it was already moving out of the solar system. Sort of like finding a visitor to be interesting when the visitor is already outside your front door into the dark street. It's a bit late. But pan-stars discovered it after a few years. So, you know, if we continue to monitor the sky for a few more years, we'll find another one. And there would be the Vera Rubin Observatory, much more sensitive than pan-stars, to be operational in less than 3 years in Chile, that could find one such object every month. So we will have many more. And, you know, we can take photographs of them. A picture is worth 1,000 words, usually people say. But in my case, a picture is worth 66,000 words, the number of words in my book. We could easily tell the difference between a rock and an artificial object from a picture. So why do I think that it might be artificial? Well, there were about 6 anomalies, 6 strange properties of this object. Well, as I mentioned first, the mere existence of the object implied a much larger population of objects than rocks that we expected from other stars. It originated from the local standard of rest, which is unusual, only 1 in 500 chance. Its brightness changed by a factor of 10. That was unprecedented for rocks in the solar system. It means that it has an extreme shape. The best fit to the variation in the light as it was tumbling was that of a pancake shape, not cigar shape. And there was no heat detected from it. And since we know the surface temperature, we know the trajectory, so we know how much it was heated to, the fact that we didn't detect any heat or infrared radiation from it implies that its size is less than 200 meters, which is roughly the size of a football field. And it also implies that its reflectance is quite high. If it were 20 meters, then it has to be just like a mirror, perfect reflectors. But it was about 200 meters or less. We don't know exactly the size. And then the most important anomaly was that it deviated from an orbit shaped just by the sun's gravity. There was an extra push. And if that push came from the rocket effect, from the fact that there is outgassing, evaporation of this object, just like comets show, then about 10% of its mass had to be evaporated to give it this extra kick. And that's a lot. We would have seen the cometary tail as we see for regular comets, for sure. And in fact, the Spitzer Space Telescope looked very deeply around the object, didn't see any gas or dust. So the limits on the amount of evaporation on carbon-based molecules or dust are very extreme, orders of magnitude below what's needed to give it that extra push. So the question is, what did give it that extra push? And the only thing I could think of is the reflection of sunlight. And that requires the object to be very thin, just like a sail, a light sail. But nature doesn't make light sails. So maybe it implies a technological civilization. Now, there were other proposals to explain this object after my paper was published, arguing for a natural origin. One was that maybe it's a dust bunny, a collection of dust particles that are held loosely together. You need this object to be 100 times less dense than air so that the reflection of sunlight will give it the needed push because it's lightweight, sort of like a dust cloud, 100 times less dense than air. The problem is that when such an object gets close to the sun, it will be heated by hundreds of degrees. And I find it hard to believe that it will have the material strength to withstand that heating and stay together. Another suggestion was it may be a fragment from the disruption of a bigger object that passes close to a star. The problem with that is usually when you get tidal disruption of an object, you end up with elongated, cigar-shaped fragments. This object was at the 90% confidence pancake shape based on the reflected light from it. So that doesn't work. And then there was a suggestion of a hydrogen iceberg, a chunk of frozen hydrogen, so that when it evaporates, you won't be able to see the cometary tail because hydrogen is transparent. The only problem is such a chunk of frozen hydrogen would not survive the trip. We showed it in a paper that we wrote afterwards showing that as a result of absorbing starlight, such a hydrogen iceberg would evaporate very quickly. So it couldn't be a hydrogen iceberg. We've never seen a hydrogen iceberg, by the way. Not to speak about the size of a football field. We haven't seen even the size of a dust particle, a chunk of frozen hydrogen from space. This is an excerpt from one of the early book reviews about my book. I didn't understand a couple of words here and I asked my daughters to explain and they did. So Oumuamua is really strange. Doesn't look like a comet or an asteroid that we have seen before. Sort of like a plastic bottle that you find on the beach among all the rocks that you usually find there, in the sense that it implies a civilization potentially. And just like plastic bottle you find on the beach, usually it's not functional anymore. So this object was tumbling, you know, it was not, it didn't have a controlled motion. So if I had to guess, I would say it's billions of years old. You know, just like we send out Voyager 1, Voyager 2, New Horizons out of the solar system, in a few billion years, they will not be functional. And if anyone finds them, they would look like punctured plastic bottles on the beach. They will not be useful for anything, but they would indicate that whoever the sender is, that sender was a technological civilization. As it turns out that there was another object discovered in September 2020, just a few months ago, and it was given the astronomical name 2020 SO. This one was bound to the sun, so it was not coming from outside the solar system. It was moving on an orbit similar to that of the Earth, and it also exhibited an extra push by reflecting sunlight without a cometary tail. And then the astronomers that discovered it on Pan-STARRS, the same telescope that found Oumuamua, the astronomers realized, oh, it actually came from the Earth. It was a rocket booster that was launched in 1966 from Earth towards the moon, a lunar lander mission. And this was a relic from that mission. And the reason it showed an extra push away from the sun is because it has very thin walls. It's hollow. So it has a large area for its weight. What you see in this orbit shown here in the movie above is the motion of this object relative to the Earth, not relative to the sun. So we know that 2020 SO behaved just like Oumuamua. And we also know that this object was produced by us. The only question that remains is, who produced Oumuamua? And this is the way it looked like the rocket booster on the right side. Anyway, there was another object found, another object from outer space called Borisov. That was the second object discovered in 2019 by a Russian amateur astronomer named Gennady Borisov. And this one looked just like a comet. So I was asked by others, oh, doesn't it convince you that the first interstellar object was also of natural origin? To which I said, you know, if you find a plastic bottle on the beach, and after that you find a lot of rocks, that doesn't change the nature of the plastic bottle. Another way to put it, when I met my wife, she looked special to me. The fact that I met other people afterwards didn't change my impression. So in fact, it goes the other way. If Borisov looks like a comet and Oumuamua doesn't at all look like a comet, then Oumuamua is really strange. And the fundamental question is, did Oumuamua originate from an artificial production or from a natural origin? In both cases, it's something that we have never seen before, because all the alternatives to the artificial origin that I proposed also invoked something that we have never seen before, like a hydrogen iceberg or a cloud of dust particles. You know, we've never seen that. So my point is simple. Why not collect more evidence about the next object? Why not take a picture of it and see what it is, the next one that looks as strange as Oumuamua? The only reason we might not do that is if we listen to the majority of the astronomers that say, I don't really care about these anomalies. I don't want to get into the details. I know that it's never aliens, that it's always rocks and always natural. So just business as usual. Let's not even worry about it. If you're not ready to discover new things, you will never discover them. So here is the history of the universe, starting from the left with the Big Bang and ending up at the present day on the right side. And the reason I put this out is just, well, I worked most of my career actually on the dark ages when the first stars formed, which you can see about 100 million years after the Big Bang. But the reason I put this here is that our technological civilization, the technologies we developed, came about only over the past century. And that is 1 part in 100 million of the age of the universe since the Big Bang. It's really a short time. And most of the stars formed before the sun, billions of years before the sun. So they could have had a technological civilization like ours billions of years ago. And if those sent out probes, just like we sent Voyager 1, Voyager 2, New Horizons, there should be a lot of plastic bottles in space. We just need to search for them. And most of them will be old, billions of years old. And of course, the type of civilization that you may get depends on which star they're neighboring. And you know, the habitable zone depends on the temperature of the star. You can see it here. But the point of the matter is we can search for other technological signatures that are different from just the relics they leave behind. We can search for industrial pollution in the atmosphere of those planets, and that's a subject of a paper that I wrote. We can search for photovoltaic cells on the day side that converts starlight to electricity. We can search for artificial light on the night side. We can search for beams of light that are propelling light sails, just like the Starshot project. And when the light leaks outside the boundaries of the sail and sweeps across our sky, we would see it as a flash of light. So we can search for flashes of light. We can search for a swarm of satellites surrounding a planet when it transits a star. We can search for big structures, megastructures, lots of ways to search for technological signatures. And currently, there is very little funding for this search, a factor of 1,000 or so less than the funding given to the search for dark matter. We don't know what most of the matter in the universe is. And there are various proposals, like maybe it's an axion, maybe it's a weakly interacting massive particles. And hundreds of millions of dollars were invested in such searches with nothing found so far over the past few decades. But if you think about it, what impact will the nature of dark matter have on our life? Practically zero. If it's an axion or a weakly interacting massive particle, it wouldn't change anything. But think about the answer to this question. Are we the smartest kid on the block? If we figure out that there is another technological civilization more advanced than we are, that would have a huge impact on society. Nevertheless, this search is funded at a level that is 1,000 times less than the search for dark matter. How is that possible? When the public is so curious about this question and the public funds science, at the same time, the scientists are ridiculing discussions on technological signatures. I mean, the search for primitive life, it is by now part of the mainstream of astronomy, but the search for technological signatures, by no means. You know, when I proposed that Oumuamua may be a technological relic, it was ridiculed all over the place. So I ask why? Why not engage? Why not put it on the table and aim to get a photograph of the next interstellar object that looks weird? Why should it be ridiculed? It's just, it could be part of the mainstream, and I call it space archaeology. Just like we have archaeology here on Earth, you know, we cannot go have a phone conversation with the Mayans. The Mayan culture is not around anymore, but we can find relics from the Mayan culture in archaeological sites. So in this much the same way, we can find relics of technological civilizations in space, and that would be space archaeology. Instead, for 70 years, we searched for radio signals, which is equivalent to trying to have a phone conversation. But to have a phone conversation, you need the counterpart to be alive at the time that you're having the conversation. And if they're not alive anymore, who would you speak with? So my point is, there is extremely low level of funding. It's going in a different direction that is not necessarily producing anything. And the public is so interested. So why wouldn't the mainstream of scientists embrace this possibility and just collect as much evidence as possible? That's one of the main messages of my book. By the way, in my book, I also have a discussion about light sails. In principle, you don't need a very powerful laser to accelerate them to a fraction of the speed of light. You can just park them around a massive star at 100 times the Earth-Sun separation. And then when the star explodes as a supernova, it produces a flash of light that can push these light sails too close to the speed of light. So then it will be like dandelion seeds. You can see that on the photo on the right, that are carried by the wind. Enrico Fermi, a very famous physicist, asked the question, if there are civilizations out there, where is everybody? Well, to me, that sounds very arrogant, because I don't think that we deserve a visit. When I met my wife, she had friends that used to say, I'm waiting for Prince Charming on a white horse to come over and make me a marriage proposal. That never happened. Why should we pretend that we are so special and interesting for someone to come and visit us? I think that we are so common and uninteresting. We developed technologies only over a century, which is a very short time. We weren't at all interesting 10,000 years ago. Why would anyone pay attention to us? We are just like ants on a sidewalk. You don't pay attention to every ant when you see a lot of them on the sidewalk. So I would guess that we don't deserve a visit. And moreover, very advanced civilizations might decide not to engage in contact with lower level civilizations because that would degrade their quality of life. So they may close themselves in a cocoon and we would never see them. But that doesn't mean that we cannot find that they exist, because they need to throw some trash. And just like investigative journalists that go through the trash cans of celebrities in Hollywood, we can search through their trash to find out more details about their private lives. Most likely, most technological civilizations are dead by now because they live a short lifetime. We see how we behave, right? We don't preserve the climate, and maybe we will live for just a few more centuries and that's it. But we can still do space archaeology, search for the relics, those Voyager 1, Voyager 2, all these space probes that they sent out. And my hope is that finding relics of technological civilizations that perished because they misbehaved will encourage us to get our act together and avoid a similar fate. And as you all know, the Perseverance rover landed on February 18th on Mars and is currently looking for signs of primitive life, microbial life. Let's all hope that that will be the first discovery of biological life beyond Earth. Thank you. And I'll be glad to take any questions you have.
Thank you so much, Mr. Loeb. Everyone is clapping. I don't know if you could see it because they have the microphones off, but everyone was clapping. Thank you so much. It has been a pleasure to hear you. Your point of view is no doubt really interesting. Now let's move on to the question and answers round. I'm gonna start, but first, did you say that your birthday was on Friday?
Yes.
Oh, happy birthday!
Thank you. Well, at this point in my life, I have to count backwards. I don't know how many years I have left, but probably I passed the middle point by now.
Okay. Now, I have here your book, and you said your thoughts about the scientific community. So I want to ask you, why do you think the scientific community has such a conservative mindset? Because you said they talk about the multiverse, the extra dimensions, like these are common, but we have no evidence. But well, when we talk about intelligent life beyond Earth, they are so reluctant. So what do you think? Why do you think they?
Yeah, I don't think it has to do with being conservative, because as you say, there are much more speculative ideas that are being entertained as part of the mainstream. The main difference between those ideas like extra dimensions, the multiverse, supersymmetry, string theory, the main difference between them and the idea that we could search for technological signatures is that those ideas involve very fancy mathematics, and they allow people to demonstrate that they are smart. And so, these scientists that work on these subjects, they feel that they elevate themselves on a pedestal relative to the public. They do things the public cannot really follow. And at the same time, they demonstrate to their colleagues how smart they are. And so then they can get honors and awards. And explaining nature is really of secondary importance in the current, academic culture, which is quite unfortunate because, it's really, physics and science is really about trying to figure out the world, and that was the original intention. But now it became an obsession with maintaining an image such that you get honors, awards, and recognition. And, that is wrong, because if you look at Albert Einstein, for example, he made 3 mistakes in the last decade of his career. He argued that black holes don't exist, gravitational waves don't exist, and quantum mechanics doesn't have spooky action at a distance. And all 3 were proven wrong by later experiments. So it's a completely legitimate thing to make mistakes, because it's a learning experience. When you work at the frontier, you don't always know the truth. You have to put some skin in the game. So just like kids put skin in the game, they get bruised, right? Literally speaking, they put skin in. But unfortunately, my colleagues do not want to put skin in the game, because if you make predictions that experiments can falsify, then that will taint your image. People would say, oh, he was wrong or she was wrong, made a prediction that didn't turn out to be correct. So it's better not to make predictions. It's better to work on fancy mathematics and just do intellectual gymnastics, showing that you are smart, and you are never at risk of being wrong. But my point is, that's not physics. Physics is about trying to understand nature. And you might do these gymnastics, intellectual gymnastics, on a concept that has nothing to do with reality. So what good does it serve? It's just like shoemakers deciding at some point to bake cakes. Okay, they can bake cakes. I have nothing to say about that. But the problem is that they should not call themselves shoemakers anymore. So these physicists that do not try to explain nature, but just demonstrate that they are smart, should not call themselves physicists. So that's my problem. And it's now the prevailing culture. And when you have a large enough group of people that agree to do that, then it becomes the norm. It becomes the mainstream. And if someone talks about a relic of a technological civilization, that doesn't sound like something they want to engage in, because it may be controversial. It will not necessarily boost they look at each other and stay in the same mindset. So the point is that I think that in order to find new things, you need to be open-minded. The philosophers during the days of Galileo refused to look through his telescope. And they said, we know that the sun moves around the earth. Otherwise, it would take them out of their comfort zone. And that comfort zone was advocated by Aristotle 1,000 years earlier. It was flattering to their ego to believe that the earth is at the center of the universe. And Galileo was put in house arrest. By the way, I'm in house arrest because of the pandemic, so not because of my colleagues, but nevertheless, the point is that people usually prefer to be in their comfort zone. The other thing about it is, the general public, there are lots of reports about unidentified flying objects. There is a literature about science fiction, and many of the scientists prefer not to be linked to that because it's not scientific enough. And my point about that is, if you go back to ancient history, there were people that argued that the human body has a soul and you should never dissect it, that anatomy should not be allowed. Now imagine if scientists would say, oh, the human body is a controversial subject. Some people talk about the soul, other people deny that. We don't want to do any anatomy. We don't want to deal with that scientifically. Where would modern medicine be? The point is, the it's the obligation of science to engage in a subject of great interest to the public if the scientific community has the tools to address it and clear it up. And that's exactly what astronomers have. They have telescopes and instruments that can answer the question, are we alone?
Thank you so much for your answer. I really enjoyed your explanation. We have someone here, Jorge Alonso, who wants to ask you something.
Please go ahead.
Let me see.
Hello, Abraham. Can you hear me?
Yes, I can hear you.
Okay, thank you very much for your conference. That's very interesting, and I'm very happy to stay here and hear about the science and the new experience in the universe. My question is simple. Where is the next planet experimentation to prove that it's correct or not correct? So
Yes.
what is the next to do? That is my question. Thank you so much.
I actually wrote last week an essay that went to Scientific American. It will appear probably in a few weeks from now, answering your question, exactly your question. And in my view, the next step is to do space archaeology of the type that I was talking about in my talk. And the way to do that is to deploy cameras within the orbit of the Earth around the sun, such that the next object that comes from interstellar space that looks as weird as Oumuamua will pass close to one of the cameras, and we could get a close-up photo. And as I said, the picture is worth, in my case, 66,000 words. So from a good picture, high-resolution image, we can tell if the object is a rock, natural, if it's a dust cloud, if it's a hydrogen iceberg, or whether it's a piece of technology. We can tell just from the image. And that's what we should do. Now, there are two ways to do it. You can deploy a huge number of cameras, each of which will not be very expensive, in space ahead of time, and then one of them will be close to the trajectory of that object. Or another approach is, if the object is identified early enough, and that would be possible with the Vera Rubin Observatory, if it's identified far away, then you have a warning time of 1 year. And during that time, you can launch a special mission that will come close and intercept the trajectory of this object, and you can take a close-up photo. So that's, in my view, that should be the next step. And I hope that, someone will do it.
So now the more important thing to do is watch the thing, because it's not possible to get information for others interactions. You know what I mean?
No,
so the more important thing is watch it for the form.
No. So Oumuamua,
and with that information, you can do it.
Yeah. So we cannot.
Sorry, that's it. This is my question.
We cannot continue to observe Oumuamua. By now, it's 1 million times fainter than it was close to the sun. So what we need to do is wait for the next unusual object that belongs to the same class. And when I go to the kitchen and I find an ant, I get alarmed because I know there must be many more ants like it in the kitchen. And so the fact that we found Oumuamua within a few years of looking with Pan-STARRS means that we will find many more. Especially with the Vera Rubin Observatory, we might find one every month. So there will be more objects like it. And what we need to do is next time around, pass close, take as much data as possible about the object from a distance from the Earth, but also try to get a camera to come very close to the object so we can get an image. We couldn't get an image of Oumuamua. It was too small for its distance.
Thank you so much. We have 2 more questions. Antonia Varela, who is the director of the Starlight Foundation, emerged from the Astrophysics Institute of Canary Island, wants to ask you something.
Please. Oh, you should unmute yourself. We cannot hear you.
Unmute your microphone, Antonia Varela, please.
Sorry. Okay. Thank you, Aisha. Thank you, Professor Loeb. It's a pleasure to, it's a very nice and interesting conference. My question is more related with the Pan-STAR one survey. How does the Pan-STAR survey compare to other surveys as a SLOAN, for example, digital sky survey? And what are the next challenges and observations required in order to determine the natural or artificial origin of Oumuamua and many, many other objects that probably in the future you will detect it?
Well, thank you very much. This is an excellent question. First, I wanted to say that I heard great things about your observatory, and I hope after the pandemic to come and visit you. I heard that it's a beautiful location, and we were planning to go there one day with my family, but maybe in the future. Now, with respect to Pan-STAR, I should say that an object like Oumuamua could not have been discovered before Pan-STARs, because what you need is a telescope that surveys the entire sky, not just a small portion of the sky. And there wasn't anything at the level of Pan-STARs. I mean, there will be, in less than 3 years, the Vera Rubin, the LSST on the Vera Rubin Observatory, much more sensitive, but Pan-STARs was really the first. It was a pioneer in that sense, and it was initiated because of the task that the Congress gave to NASA to find the 90% of all objects above 140 meters that will pass close to Earth. As I mentioned, the dinosaurs were killed by an object the size of tens of kilometers that hit the ground, and Congress in the US issued a task to NASA to find all objects that are bigger than 1% of that rock that killed the dinosaurs. So Pan-STAR started this search, okay, for near Earth or objects, and that's why it was initiated. In the process of surveying the sky, it discovered Oumuamua by chance after a few years. And then the Vera Rubin Observatory will be able to detect about 60% of all near Earth or objects bigger than 140 meters. And so that's really the highlight of the next, within a few years. The only risk currently to LSST on the Vera Rubin Observatory is the constellations of communication satellites that are being launched, especially by SpaceX, planning to launch tens of thousands of them, because when they move on the sky, they reflect sunlight. And there is a plan perhaps to color them in black. It's not clear how successful that would be, but they still pose a big risk. And I've been at a number of discussions on this issue, which is a risk. But other than that, LSST would be an amazing instrument. It would be much more sensitive than Pan-STARs and could detect an Oumuamua-like object every month. And so that's really where the future is. I really am waiting for LSST. Because of COVID, it was delayed by a year. So the science will start according to the last report I heard, will start in December 2023. That's when the science will start to come out. And then, of course, in the subsequent year, we hope to see more objects like Oumuamua. And then my hope is that people will listen to my advice. I'm not an instrumentalist, but what I'm arguing for is having a camera take a close-up photo, just like going on the beach, and looking at the objects that you see. And every now and then you might see a plastic bottle. So just examining all the weird objects that enter the solar system that are interstellar in origin, do not behave like a comet or an asteroid, and take a photograph. My point is, even if it's of natural origin, it's something that we have never seen before, according to the models that were put on the table. So we will learn something new. I don't have a vested interest just in an artificial object, but potentially, even if it's natural, we will learn something new about new birth sites or factories of objects that we have never seen before. So that would be a new frontier, I think, studying interstellar objects in our neighborhood, near the Earth. I think it's a new frontier in astronomy, which is not highly well recognized, but it could serve the purpose of space archaeology for relics of others. And imagine if we find a technological relic, we could potentially land on it and examine the technology and maybe look for a label that says made in planet X. We might learn where it came from or what its purpose was. Maybe we can import the technology to Earth, and that could advance us by 1,000,000 years, because that's a technology that we haven't developed yet. So altogether, it could be extremely exciting. And by the way, science doesn't need to be boring. Why do we always, in the academic world, there is this notion that, things need to be boring because you shouldn't get too excited, so people talk forever about the same thing again. And no, science could be exciting. Why not check if there are things coming to us from other civilizations? That could be particularly exciting.
Thank you very much. And you will be very welcome here at the Canary Islands.
Oh, we will be
Yeah,
delighted. Thank you.
You are. And the last question we have is from Alessandro, who says, could you please ask him the following? What do you think about actual theories about extraterrestrial visits to Earth in the past?
Oh, yeah. So on that, I don't think that we are particularly interesting for a visit. So as a matter of cosmic modesty that I try to advocate for, we developed technology only over the past century. And, before that, we were not interesting. And even now, we are relatively probably primitive. We are not sophisticated. So I would guess that nobody bothered to come here in the past. That would be my guess, out of modesty, and I would think that nobody pays attention to us. Now, when you enter a room full of strangers, you better be quiet, because you want to listen first before you speak out. You never know whether there are predators in the room that could risk your existence, right? That would be the smart thing to do. Now, we were not smart in that regard either, because we transmitted radio waves for more than a century into space. And if there is any civilization out there that has radio telescopes, they know about us. And we might hear back from them in the coming century. So we were not careful. We were not very smart on that.
We have one more question. This is the last one. It's from Dragana, and she says, are you afraid that your theory will be misinterpreted or spread by pseudoscientific or sensationalist media, and that it will reach the general public distorted?
Yeah, so I'm doing my best to explain what I mean, and so to anything you do, there could be positive or negative implications, right? So you have to be careful. And the positive that I see is that I communicate the excitement in science, and I address a question that is of great interest to the public. And that explains why my book is getting so much attention. It's basically a bestseller, in the US, in everywhere that it came out. It was just a bestseller 2 days ago in Germany, a week after publication, and it gets a huge amount of attention. There were about 270 interviews that I had to take over the past 7 weeks, basically every day from 8 a.m. till 7 p.m. And that was full time for me, back-to-back interviews. And there were 24 filmmakers and producers that approached me with interest in the book, making it a documentary or a film out of it. So clearly the public is starved from the scientific community on this subject. And I said to my publisher that I write this book with the hope that there would be one kid somewhere in the world that will decide to become a scientist after reading the book. And a week ago, I got an email from Malawi in Africa from a woman that wrote to me, the book is great, and I'm thinking of becoming an astronomer. So I told her the story about the publisher, and I said, are you that person? Are you that person that will become a scientist thanks to reading my book? And she said, maybe. So I'm already satisfied.
Okay, I'm really inspired by your book. And now, thank you so much, Mr. Loeb. It has been a great pleasure to have been talking to you these weeks by email. And thank you so much for this conference. I'm really grateful to have been able to do this conference with you. Thank you so much again. And before you leave, the founder director wants to say goodbye to you.
Thank you for hosting me.
Happy birthday.
Thank you.
And thank you so much. It's very interesting and exciting. It has been a great honor and pleasure for us. We hope that someday you might wish to get to know our Starlight Estelar Park in Tenerife. And my best wishes. And thank you very much again.
Thank you. And for me, it will be a journey back to my roots. You know, as I said, half of my DNA is Spanish, and that's the better part.
Thank you so much. Thank you so much.
Thank you.
Bye-bye.
Bye.
Muchísimas gracias a todos. Ha sido un gran placer esta tarde poder contar con Mr. Avi Loeb. Ha sido algo magnífico. Estamos de verdad muy ilusionados. Esta sonrisa creo que me va a durar muchas semanas. Así que muchas gracias y buenas tardes.